Let's get into it. So we are going to kind of piggyback off of the previous session and get into a little bit of what Jack showed about writing some rules. Did you get that rule to fire, Jay?
I did. Yeah, I had an errant
I knew
double
it.
quote.
I knew it.
Yeah.
You're a professional. All right. So my name is Jay. I am a research analyst at Emerging Threats, and we write IDS rules for everything from phishing to malware to annoying pop-ups to you name it. If it goes over the wire, we want to write a rule for it. Do a lot of malware analysis. I do a lot of phishing research and write all the phishing rules, as well as some clam AV. And I teach a class with Jack about how to write rules. Did you want
Yeah.
to?
Yeah. So, yeah, this is going to be kind of like a hyper condensed version of that longer workshop class. But yeah, my name is Jack. And for anyone who wasn't around in the previous session looking at threat hunting with Suricata, um, you know, I was there. I'm a security research analyst with the Emerging Threats team with Jay. Us, along with some other folks, spend all day looking at packets, looking at malware, trying to figure out how malware does the bad stuff and how we can stop it or slow it down. Yeah, and in addition to that, I love looking at malicious documents. I love researching new document exploits, macro usage. People love to dig into Excel forums from like the 90s and pull out really weird, obscure things, and it's fun to kind of track those down and write SIGs on them. So at any rate, yeah, that's a little bit about me.
What are you going to be doing tomorrow at 5 a.m.?
I will be waking up at 5:30 in the morning Mountain Time to watch my favorite soccer club, Liverpool, play their crosstown rival, Everton.
I'm going to try to be there. We'll see. All right. So why IDS IPS? This is a question that we get all the time. Is it still relevant? Is it still valuable? And combined with all the other tools in your arsenal, we think it's incredibly valuable. It's still incredibly applicable when you're discussing things like defense in depth. You need some host monitors, you need some network monitors, amongst many other things. There are some drawbacks to using it and some things that you can't see. But what we try to do is provide context about what's going on your network. We don't always want to say every alert that fires on my network is malware, it's malicious, it needs a DEF CON approach. We just want to give you all the information that you might need about what's happening on your network without digging into gigs and gigs and gigs of traffic. So that's kind of the approach that we try to take. When we have full PCAP, we can augment that with some of the tools that were shown in the previous session. But for this, we're going to keep pretty strictly to writing the rules. When we write the rules, we kind of want to strike a balance. We don't want to write a rule that's going to have false positives, obviously, but we don't want to write a rule that's too restrictive, such as writing a rule on just a host name, when we could be writing it on some other contents of the traffic that are harder to change. We don't want to write things that would uniquely identify one single piece of malware, but we want to try to identify the family by finding lots of correlating samples, by finding lots of traffic from samples that are of the same family, so that we can provide a comprehensive type of view on what that traffic looks like. But that can be tough. Sometimes you only have a single sample. Have you ever been in a dark forest with a single sample, Jack, and you got to write a rule on it?
I mean, yeah, even worse, you have a screenshot of Wireshark and some bytes, you don't even have the sample because whoever wrote the blog decided to not include IOCs, which is always great. And yeah, it's tough, it's definitely what makes it hard, but that's what comes into the rule writing kind of theory, is taking, a little bit and turning it into something better. Hey, let me see if I can share my screen. Hey, Naomi, can you maybe remove Jay? There we go. Yeah, I can share my screen. It looks like maybe there's a little bit of a technical difficulty there. Just 1 second, get it pulled up. Sorry, everyone. Let's see where we were. There we are. Okay, computers, am I right? One second here, folks. There we are. All right. Okay. Is everyone able to see the slides? Uh-oh. Okay. Sorry, Zoom's having a little bit of a day. Okay. I've lost my Zoom window now. Sorry, everyone. This is a catastrophe. 1 second. Hey, sorry about that.
Yeah, wow. So that's a first for me. All right, so give me a second. Sharing the screen. Computer literally blue screen. Well, it's a Mac, so it's like black screened. All right. All right, do we look okay here?
Yeah, it looks good.
Okay, so we're gonna go through kind of how to build an IDS rule that's going to make sense, be performant, and uh, per, and detect this traffic that we're looking at right here. If you've already looked at rules, you've already looked at lots of traffic, you might see some obvious things, but we're kind of going to go through and pick out the things that make the most sense here. So Jack?
Yeah, thanks. Cool. So yeah, we're going to start with just kind of the basic IDS rule format. If anyone was on our last session, kind of going through threat hunting, we very briefly kind of stopped in the rules department, but here we want to kind of expand that out and hopefully, provide some more context to that. So the basic foundation of an IDS rule begins with an action, kind of highlighted there in blue. Following that action, we have a protocol. And then from that, we kind of have the what, so, or the who, I should say. So the from IP and the to IP. So this is kind of the conversation of where the traffic is heading. We can provide a message. So this is actually the text that'll appear in various logs and alerts that inform us, like, what is this rule actually doing? And then we have the actual meat of the rule, which is the content. So what are we actually looking for? Whether it's a string, whether it's a flag in a protocol, what are we actually trying to detect? And then following that, our last but not least, we have just some metadata, right? So what is the unique signature ID? Are there any references we can point this to, an MD5 hash or a URL, and a revision number. So that way, if we edit this rule, we can kind of keep track. And we'll kind of dig into each one of these. So beginning with that, we have our rule action. So this tells Suricata or Snort what to do when this traffic matches. So 99.9% of the time, we will always use alert. This essentially generates the alert, creates that log, gives us something saying, hey, we saw this fire, but it ultimately will let the traffic go through. This is for, again, 99.9% of the time, often because, as emerging threats, we don't want to tell you when to, destroy your traffic, but that's kind of up to each environment, right? Another one that we can do is log. So in this case, we're just logging traffic, but we're not actually generating alerts. Not sure why you'd want to use this one, but I never do. We can create a rule that does pass. So this will actually ignore the packet and then allow it through. So this would be good for like whitelisting. And then we have kind of the big burly drop. So if we're in IPS mode, we can actually drop the offending packets, ultimately terminating that connection. Again, this is something that, if you're running in IPS mode, you should know what you're doing, and you should have, some good backup should anything go wrong. Jay, I think you know a thing or two about that.
No, never, nothing, no, never.
But, yeah, you never know what kind of presentation or something you might be killing. It could be a Zoom session, it could be a big sales meeting, right? So anyway, that'll actually just terminate the connection and then reject. In a similar way, we'll actually send a TCP reset packet back to the originator of that connection, rejecting that traffic. So once we declare our rule action, we can actually move into our rule protocol. So once we've determined what we want to do with the traffic, we can tell Suricata, hey, what are we actually looking for? Suricata and Snort have the ability to detect basic protocols as declared by the rule writer. So the basic ones would be like TCP, UDP, ICMP, and IP. However, Suricata is different from Snort in the sense that it is protocol aware. So instead of saying, look for TCP traffic on port 80 for HTTP, we can actually just say alert HTTP. And Suricata will detect that HTTP traffic no matter what port it's on, whether it's 80 or 8082, like in our previous example. Any port, it doesn't matter. And this is really powerful because we do see a lot of malware like TrickBot in that last session doing just basic things like getting off of non-standard ports to kind of throw a wrench in a defender's plan. We can also apply this logic then to other protocols like TLS. This is a really big one. This is a really cool way to find some interesting certs, especially when they're not on standard ports. DNS is really cool. DNS actually includes TCP and UDP. So with Suricata, if you just say alert DNS, it doesn't matter which protocol that is, whether it's TCP, UDP, it'll just detect it. and SMB for people who like to torture themselves and look at SMB traffic. We can actually, from a protocol aware perspective, detect using alert SMB for that specifically. So now that we've kind of determined what to do with the traffic and where to look for it, we can determine the rule host variables. So this is kind of where we establish the conversation of who is sending traffic to who. Now, these variables are configurable in both the Suricata YAML and the snort.conf file. Both do contain defaults that will work kind of right out of the box, but I would, ensure that it'll work by double checking them just to make sure it lines up with whatever environment you intend to monitor. So for example, at the very basic, we have HomeNet. This will refer to any internal network. By default, it's typically your RFC 1918 network blocks, but again, configurable. And then with external net, typically that is just not whatever isn't defined in your home net variable. So again, that's where you should kind of dig into that YAML or comp file, take a look and see exactly what's happening under the hood just to make sure. But then you can get crazy. You can start declaring your own variables. You can say, hey, if you have a mail server on a certain IP address, instead of typing out that IP address in all of your rules, you can just use simply the variable as you establish. So it's really powerful and it can be great. And if you do want to type out that IP address, you can. You can just use an IP address or a range in your rule instead of declaring a variable. But if I were you, I would just stick to using a variable, and it's just a little bit easier.
Yeah, variables are the best.
Cool, so rule direction. So when we do establish our rule host variables, we can just state the direction by using this little ASCII arrow, like we'll literally put in the rule that like dash and greater than sign. So this tells the engine what direction traffic is flowing between hosts. So if we wanted to look at just an internal client reaching out to an external network, we would do HomeNet any, and then put that arrow direction pointing towards the external net. This is indicating, hey, we're coming from our internal network and talking outbound. If we wanted to look at things coming inbound, so let's say, an executable download coming into your network, we would do external net and then put the ASCII arrow pointing to HomeNet. And then last but not least, we can be bidirectional. I wouldn't recommend it just from a perf perspective, but we can then, just use those two greater than less than signs to, basically just indicate, doesn't matter what way, we're going to inspect both sides of the traffic, and if it matches, it matches. But from a perf perspective, it can be a little bad. So rule ports. So this is used in tandem with the kind of rule host variables that we declare. So in this case, we could say something like alert TCP, HomeNet any to external net 9003. In this case, we're looking for TCP traffic originating inside of our home net on any port, and we're looking for it to go out of our network onto port 9003 only. So that's a very specific, we're only looking for traffic going to a single port number. So, again, we can get pretty specific, but it just depends on what you're trying to detect. Like the hosts variable, you can actually, create your own port variables as well. So if anyone's familiar with Snort, you might be familiar with using the $ HTTP ports variable. This is actually a huge list of various ports that Snort has identified as being HTTP. It can be a source of false negatives. So definitely, if you're using Snort and use that variable, look into what ports are actually in use there. But you can also configure your own. So if you have, servers on your network or something that are only using specific ports for various services, you can create that variable in the same way you would do the rule host variable. Again, this is all just kind of for ease. And another cool thing we find ourselves using a lot is negations. So we can actually just place a exclamation point in front of, whether it's a rule variable or a single port or anything, we'll actually basically be saying external net, not port 80. So that can be a really powerful tool as well. But, again, all of this can get complicated really fast. So, like we mentioned, start small and build from there. So kind of continuing on the rule ports, we can express them in various ways. So we can do something as simple as list a single port. Using brackets and commas, we can list out multiple ports. Using a colon, we can indicate port ranges, and these are inclusive. So in this case, we'd be looking at port 8000 all the way up until 9000. So any port in between is valid. And we can combine. We can get kind of crazy. We can say, you know, on HomeNet, I want to look at ports 1024 and above. And I want to look for any traffic on those ports going to the external net on port 80, 800, 6667, 26669, but not port 200. We don't like port 200. So yeah, so it's kind of cool. You know, we can definitely get advanced with this. And, you know, this is a good thing to knock out false positives and also, you know, improve performance on your rules. But again, it can lead to false negatives quickly, you know, so just keep that in mind.
Yeah, that's where we talked about this balance. And we're never going to write a rule that's only going to detect something on a port. So we will always have contents and whatnot. But this just kind of is here to show the flexibility of kind of what you can do with that part of the rule.
Definitely. Does anyone in chat want to fill in the blanks on what setting up our rule foundations might look like based on this traffic that's highlighted here? We've kind of configured our Wireshark to, you know, provide some of the details like ports and things like that. But
I know chat can do it. I have faith.
send 1 Bitcoin to someone that answers this.
Yeah, one of Jack's Bitcoins.
All right, so yeah, we have one kind of idea here. So we'd be saying alert HTTP. Great, you know, we are looking at the HTTP protocol here. And then for our first variable, we would say HomeNet. Yeah, perfect. And we'd say any port, as we see here, yep. And our direction, you know, not HomeNet, and that's basically using external net, because if we have established our home net, then our external net is basically not the home net. So yeah, we'd basically be saying alert HTTP home net on any port going to external net on any port. And you know, I think for Suricata that's perfect. And if we're using Snort, we just have to do it a little bit differently based on the way that works. So yeah, very good.
I knew chat would come through. Well done.
Cool. So just kind of moving on, once we've set up those baseline sort of foundations on our rule, we just need to do the easy part, which is give it a message. So what actually happens when this rule fires? What are we going to see? You know, I feel, you know, strongly about this just as an analyst who's read rules that don't make any sense, written by people who are no longer with the organization. And, you know, you're digging through no documentation to figure out what that means. So yeah, so, you know, typically we want to give a rule message that makes sense once we see that rule fire. For me, consistency is key. So making sure that, you know, if you're sticking to a certain kind of syntax or verbiage, just stick through it, right? Maybe have a guide that, you know, your team or yourself, you know, you kind of use and stick with. For me, you know, information is power. So adding things like architecture of malware. So if we know it's a Windows-based malware, if we know it's a Linux-based, you know, Mac-based, write that in the notes, because if I am in a Windows shop and I see a rule with OSX in the message fire, I'm going to say, either I'm witnessing a weird evolution or, you know, something's amiss here. Furthermore, you know, just giving any sort of malware family names if we're looking at malware and we're able to determine what that is. And, you know, just doing something like the action, right? What's happening? Like, what do I need to be worried? Is this like, you know, all hands on deck, you know, get the sword out, I'm cutting network cables to stop this? Or am I just maybe, you know, doing you know, walking down the hall and having a stern talking to with someone for doing something they shouldn't have, right? And so all of this can just really help an incident responder, an analyst just really understand better what's happening and what level of severity it should be, you know, met with. Yeah, see, attack, it was probably China. Yeah, there you go. You know?
Yeah, and one thing that we think about when we're writing these rules is we know that as an analyst, this is the only thing you're going to see when you have to decide what you're going to dig into at that point in time. So we try to give enough information as to you can kind of comprehend what I would need to do next if I saw this alert. You know, as an analyst myself, you know, I had to look at my share of generic .trojan alerts in AV and all sorts of, .agent alerts. So anytime we can provide more information to give context about what should be done next or what this was actually doing, that helps out.
Great. So once we kind of declare the rule message, following the foundational aspects of that rule, we can get into what actually makes up the rule, the meat of the rule, the content. So this is, essentially the unique content that makes this signature worth something, right? What are we actually looking for in network traffic? And it's hard, it's like we mentioned before, it's a balance. We want to find things that are unique. We want to find things that are going to be indicative of the activity that the message has said, but we don't want false positives, right? We don't write false positive rules, So you have to be careful on what you choose or the combination of things you choose. So when you declare a content, you simply just type content with a colon, and then all that content needs to be wrapped in a double quote. So that's where we have that as a special character. So there are a few special characters you can see there. So semicolon, double quote, you'll have to use hex for, or else it'll break your rule. So in here are just some examples of the way that you can declare rules, right? So we have a content, something, it's just a string, right? We have a content of some, and that's a hex 20 space thing. Any hex that we write in our rules, we wrap in pipes. It's nice. I like using it for declaring things like spaces or other just punctuation kind of marks, just so that way as an analyst, I'm not confused if that's one space, if that's two spaces, if that's a single quote, a double quote, the confusion can get real. And when you're looking at just tons of lines of text, it can get lost. So I like declaring any special characters or spaces using hex. And last but not least, we kind of have our rule metadata. So this is kind of the caboose of the rule. This kind of wraps up our rules where we'll always include a signature ID. You have to have one of these in your rule. It has to be a unique number. If there are any collisions, you'll run into some problems there. So definitely make sure, again, if you're writing rules and you're starting at 1, just make sure, you go up from there. If you'd like, and it's highly recommended, include a reference. You can do that by just saying reference with a semicolon. Right now, you can do things like MD5 and then a comma and provide a hash. You can do URL, and then following the comma, you can have the full URL. And for exploits and vulnerabilities, we can do CVE with a comma and the actual CVE year and number. And these are great, I don't think you need to put 50 into a rule, but 1 or 2, if you have them, is fantastic. Again, it allows for someone who is new to this rule or new to this activity and is checking in on it, gives them the jumping off point to kind of validate that. Is this a true positive? Is it false positive? Is it new? Is it old? So any information supplementary that you can provide is super great. You can do metadata. So it's a key pair valued text you just say metadata with a colon. And then you would say your key pair. So our example here is created at, and then a date. And then we have another, it's author name and the value. And these are all arbitrary. You can make anything you want. It just, has to kind of follow that key value pair sort of format. And then once you're done with your metadata, you would just put a semicolon there at the end to wrap that up. And last but not least, we have a revision number. So typically when we write our rules, they start with revision 1. That's the kind of creation date revision. And then if we had to go in because there was a false positive and we had to add a negation or something, we would bump that rev to 2 and so forth. And then that way we kind of know if we have a rule that has, 15 revisions, like it's been around for a while, it's kind of been through the ringer, not really sure about it. And it just, again, it's more information for someone to understand it a little bit more.
Yeah, for me, I can't quite remember exactly what I ate for lunch. So looking at a rule that I wrote 2 years ago, I really hope I put a hash in there because that's going to really help me out. Help your future self out and make sure you document a little bit. No, not too much, but yeah. All right, so we're going to get into maybe the easiest portion of writing rules is just writing rules for DNS. So writing rules for DNS is a super common thing that we do. You might see this domain come across your network. Maybe you're in an incident, maybe you're just tracking down some phishing. But for me, Microsoft with a node-update.com warrants some kind of response. Now, DNS signatures don't necessarily have the highest value because, of course, they can just change the domain. So we don't want to write, 5,000 DNS rules and be like, job done. But, we probably want to dig into it a little more, figure out what actual traffic is underneath the domain. But if you've been in an incident before and you're in an incident and you can just be like, boom, DNS rule fired across your sensors on the network, and you can say within 5 to 10 minutes, hey, we've got 20 hosts compromised that are calling out to this domain. That's a great start, and that's something you can definitely take and apply right away based on what's happening. So looking at Wireshark, looking at kind of the DNS section, what kind of parts are we really concerned about? We have the flag section, we have the query information. And for most simple DNS rules where we're not doing crazy regular expressions or wildcarding some sort of DGA or something, we're just looking at the domain itself and trying to make a one-to-one match on, hey, if I see a request for this, let me know. So what does this look like? In modern Suricata, we have a buffer called dns.query. And it's just the query field of the DNS request that was made. It's maybe the simplest thing we have to use. And it is known as what's called a sticky buffer. If you used to write rules, for Snort or back in the day for Suricata, initially you would write your content first, and then you would say declare what buffer or what bucket this the engine should look in. Now you don't have to necessarily use this buffer, but if you write a rule without a buffer, the engine will just simply look across all of the traffic that it sees to try to figure out where this matches. If we use a buffer, like dns.query here, the engine knows where that is, it parses it out, and it's a very, very fast match. Suricata has a lot of these, and we'll definitely get into some of them in a little bit. So here's what a DNS rule looks like in the various kind of engines that we at ET write rules for. So starting kind of at the bottom, we would do alert UDP. Let me get at the pointer here. We would do alert UDP, get our home net, any, and any to 53. We do this because we don't know if the organization with the rule is using internal resolvers. So that's why it wouldn't always be an external on this side. And we have to specify a port since we're using an older engine or an engine that's not exactly protocol aware. Then we would have our name here. And then we have to use those flags to indicate a typical DNS request, which would be, the hex bytes 01. We won't get exactly into what offset and depth do here, but that just lets you specify exactly where in the byte stream you want the engine to look. And then you have to specify what this content is down here of your actual domain. So here I'm looking for box.config with a 1.com. And the dots, if you look at a DNS request in Wireshark, they'll look like dots between the typical, if you're looking in the hex view, but they will actually be the value of the following bytes. So 03 for BOX, 6 for config, and 3 for .com, and null bytes to indicate the end of that request. So we wrote rules like this for a very, very long time. But with some advancements in Suricata 4, we were able to move this to a buffer that the IDS engine automatically pulls out. So DNS_query, and then we can say, we don't have to specify, we can specify actual dots because the engine interprets them as actual dots. We're going to say box.config.com. We use this isData@, to basically say this. We translated this up through in Suricata 5 to just say, this is the last thing in this buffer. So it ends with box.config.com. In Suricata 4 and under, we have to say, does data exist at 1 byte relative to the prior content? A little bit more of a complicated way to just say that, hey, this is at the end of this buffer. Things that you happen to do over and over and over and over and over, like write DNS rules, should probably be scripted. You don't necessarily want to write all of these rules by hand, but at the same time, we don't want to say, hey, let's dump our MISP into this tool and put 50,000 DNS rules on our sensor. You may have a bad time. May not be the best use of that. We actually have a feature in Suricata 6 that we're not really going to have time to get into called data sets, where that could be more practical use of dumping your MISP contents or your threat platform contents into IDS like Suricata. But definitely check that out if you're interested. This is the tool. It's up on GitHub. May need a slight update for the dns.query for Surrey 5, but we use it all the time. All right, Jay?
Sorry, just answering a couple questions here in the chat. Just some questions on SID ranges, which I'm providing some of the community. There's been, in terms of SID ranges, there's some commonly accepted ranges that the IDS community has agreed upon, and I've sent that into the chat.
Nice.
Okay, cool. So that's a nice look at DNS. So now we can look at SSL TLS. So SSL TLS is obviously a little bit of a blind spot for Snort and Suricata. Like obviously if the network traffic is encrypted, we won't be able to match on basic strings, things like that. We can see that it's happening. We can see that there is traffic from one host to another. We can see things like the SSL cert, but we can't actually see under the hood unless you're doing something like man in the middle, which I think would be really cool. I think it's an important thing, especially if you're doing like malware sandboxing. It can be a really powerful tool to really understand how malware is talking and how it works. One of our favorites is Let's Encrypt. Great message, great organization, but I think they're a little bit too positive about the way people use it, and we pretty much only see malware authors exclusively using Let's Encrypt for a lot of various reasons, and unfortunately there's not a good way to work with them to alert them to nefarious usage of certs they've issued for takedown. So it's kind of a double-edged sword. Like, we love privacy, but at the same time so do bad guys, right? And then we see a lot of it. But yeah, so we can do things though with SSL within Snort and Suricata. Most importantly, we can look at the certificate information. So once a client initiates a request to a server that's using SSL TLS, it'll respond back with the SSL certificate. And this is the meat of our SSL rules. So by breaking out that certificate within Wireshark, we can actually hone in on the actual certificate content. So we have things that we use often like, the cert serial number and, the cert subject. And that's really a big one. So we'll kind of focus in on, those aspects here. Exactly. So things to note too, when we're writing rules with for the SSL cert, we want to definitely remember the direction. When the cert is being served, it's coming from server. So we're looking at, external net talking to your home net in that instance. And we can kind of see this a little bit more. So if we look in Wireshark and break out that certificate, we right click, we follow TCP stream. We can see actual hex bytes here that correlate to what Wireshark can parse out of that. So things we like to key in on when we look at this traffic are represented by hex on our left here. So things like the common name found by doing hex 550403. That's kind of our jumping off point offset for that. 55040A for organization, and so on. These are all just really nice ways. Like if you're looking at network traffic, you can just kind of search through the stream and search for these bytes to kind of help situate and orient yourself in that traffic. And with Snort, we actually end up having to use these bytes quite a bit. Oh yeah. However, suricata makes it a little bit easy. So very similar to the DNS query keyword, we also have a lot of TLS SSL buffers that we can use in our rules. We've just simply grepped the suricata list keywords command for TLS, and we have a handful of different things we can use. Most importantly, we like using things like the TLS cert serial, the TLS cert subject, and the TLS cert issuer. And these make for writing rules based on TLS certificates very easy. So TLS cert subject, again, this is a sticky buffer like we saw in the DNS query keyword. We can literally match on anything that's found in the subject field of the certificate. So whether that's a specific organizational unit, a specific common name, state, etc., all of that's fair game inside of this buffer. And typically we always do the direction being external net to home net if we're trying to inspect certificate data coming into our network from an external server. And we simply would just say tls.cert subject, semicolon, and then our content. And in this case, we're looking at a domain of z55gc.com, probably very legit, and we're simply just looking for that in the common name. And we've added the no case modifier, which means, this can be in uppercase, lowercase, it doesn't matter. But as long as the cert was issued with z55gc.com as the common name, we will be able to detect on this certificate and flag it. So another really cool one is TLS cert serial. So this is really nice when we're dealing with certificates that maybe have generic or it's maybe mimicking something, or we just really want a specific way to detect this certificate. We can use the cert serial number. So quite literally, we just write TLS cert serial, and then we provide the hex bytes in a special format for cert serial. So we want to make sure we're doing the hex bytes uppercase, colon separated, but we don't have the pipes on the beginning and the end. So similar to how we've used hex in different rules, we don't include the pipes. And we just have to do it that way. For whatever reason, that's just how it was implemented, and that's how we have to use it. So for writing signatures for TLS SSL, this is what that would look like in production. So we're looking at a suricata rule. We're looking at a recent suricata rule, so 35 or 6. We'd say alert TLS. So we'd be detecting that TLS traffic, it'd be application specific or protocol specific. So we would say external net on any port because we don't need to define that. And it's coming into our home net. And in this case, we know that this is a Baza loader command and control server, and this is the certificate for that domain. So in this case, we will say the flow is coming from the server, and it's been established. And what that means is we've determined that this is it's completed the three-way handshake, and it's been initiated from the server to our client. And then we can get into the meat of the rule, which is the TLS cert subject. And in this case, we want to detect on that domain found in the common name field. And furthermore, we can go to TLS cert issuer and indicate that this has been found, it's been issued by Let's Encrypt. So we've included the various data included with Let's Encrypt certs. So that's just kind of another layer to include in our rule to make sure that we know it's associated with the traffic that we saw at the time, and the domain didn't lapse and then get reissued by a different service or anything like that. So if we wanted to do the same thing with snort, we have to do it a little bit different. It's a little bit more difficult. Here's where we're seeing alert TCP. So we're actually, indicating that the protocol is TCP, not TLS. And because of that, we have to say external net, but only on port 443, because there isn't a TLS ports kind of buffer. So we're going to say alert TCP external net 443 going to our home net. We have our same message in our same flow statement. But here, when we're dealing with snort, we have to actually do more raw byte matching to ensure that we're looking at an SSL certificate. So we're going to look for hex 16, which is usually found in certificate contents in the stream if you follow it. And following that, we have a couple more raw byte matches. Most importantly, the 550403. So this is standing for the common name field. And then we're doing a little bit of math in terms of where we're finding the next contents just based on the way the SSL certificate format kind of is. So we're just saying, content hex09, which is the length of the domain in decimal. And so we're just basically putting that relative to our common name bytes. And we basically do that throughout the rest of this rule. So we're basically just using those hex offsets for where things are found in certificates and just putting the content relative to those. Essentially, it's just a lot of work, extra work that doesn't need to be done when you can just simply type it out using the Suricata buffers. So that's how it looks in Smart. We tried to kind of automate this. We just whipped up a little Python signature that just kind of helps if you have a domain specifically, you can just type it in and it'll kind of print out various formats for the various versions of the engines to work with, just to kind of help expedite some of that stuff. Because like Jay said, if you can automate it, then you should probably do that. So feel free to get into that.
All right, and we'll kind of speed through this next section here. So we'll talk about HTTP. HTTP is easily the protocol that we write the most for, as it's always open on the corporate network. There's so much stuff going through there that analysts may miss it, but there are a lot of things that we do with HTTP. Both Suricata and Snort have lots of different buffers. And as I said before, you don't have to use buffers, but it's going to be a lot faster because you're looking at targeted areas where the engine has already pulled out the information that you'll probably want. So one example of this could be http.user agent. And we would just specify content of detox crypto. This is what's called a sticky buffer. And whereas the bottom one down here, this is called a modifier, where you spit your content first. You say, user agent 3820, the colon space, and then detox crypto. And this will be found in the HTTP header. All of these are pretty well documented for both engines, and we refer to that stuff constantly. HTTP method is one that we use a ton. Just saying, hey, is this a post request, get request, head request, options, what is this? Just helps kind of narrow down your data and make sure that you're looking at the things that you want to look at. You could, if you know that your malware or the traffic that you're trying to write for is always making a post to send out some information from the machine, you want to include that in your signature, because that's going to help cut down. You shouldn't look at every get request if you know it's a post request. So you want to be smart about writing your rule that way. http.uri, another super common field. Anything that's in the URI normalized is going to be here. We also have another buffer called http.uri.raw, which will be the non-normalized version. All of that's documented on the Suricata read the docs. Like I said, we refer to it all the time. But this we can just say generate.php. This may be a useful field to include in the signature. We have an old buffer that we can use is just called URI len, and it's just a number of how many bytes are contained within the HTTP URI field. We use that a ton when we know exactly how many bytes would be in that field. But it's up to you if you want to include it. You don't have to include it because URLs, much like domains, tend to change. The HTTP header buffer includes everything that comes after this kind of request line here. So we have things like user agent, all of the headers, everything would be found in here. We commonly use this field to negate certain things that we would expect to be there, such as an accept header or refer or a user agent. We know that typical traffic includes these things. So when we see malicious traffic that doesn't include these things, then we can utilize that to cut down on false positives, cut down on how much traffic the engine has to look at. So it can be very, very useful. One thing that's still the case is HTTP, the cookie. If you have a cookie in the HTTP header, it's not part of this HTTP header buffer, but it has its own buffer, HTTP cookie. The HTTP request body is something that we use all the time because computers are always sending out information about themselves that we don't want them to when they get malware on them. But what we would do here is we would just say, you just say the buffer http.request body, then you give it the content that you're looking for within that buffer. And in this case, we would just be looking for public key equals. We would not want to include this unless we're very sure that this would not change and was extremely specific to every instance of this malware that was deployed, which is not the case. User agent is in Suricata only. It's very fast, much better than just using the entire HTTP header. You can just target one specific field. It'll parse out the field between the user agent and the carriage return new line that's here, and it'll just take that and slap it in a buffer, and we definitely love to use that. So here's the thing that we were looking at before. We want to turn this into an IDS rule. What are some things that we would key in on? We would key in on the post, HTTP method. We talked about that buffer. We would definitely want to use that. We would want to use the generate.php, as through running multiple samples, we determined that that field does not change or did not change. And we would say that this is the end of that http.uri buffer. So nothing should exist after it to help cut down on no false positives or whatnot. We will use our HTTP user agent buffer containing detox crypto. You notice in here there was a detox crypto 2 on here. A good tactic would be to not include that 2 because maybe there was a 1 and maybe there will be an 8. So we don't want to necessarily make our rule false negative if we're including that information. And then in the request body, we would use that public key equals, just saying that that is the beginning of that buffer, and make sure that we have that there. We would negate the refer in the HTTP header names buffer, and make sure that we didn't key in on any legitimate traffic if there was. I know this is an extremely strong rule. There are some ways that, there's lots of different ways you could write this. You could write probably this rule with just this user agent, because this is not what is typically in a user agent, and it's extremely specific to one malware or a family of malware. So that's kind of how we would approach that. Same thing within the snort, and kind of this would also apply for any older versions of Suricata as well. You know, the buffers just come after the contents, and we have most of the same things here. We have the post, we have the generate.php and http.uri buffer. We do detox crypto in the HTTP header buffer, you know, public key, and what was previously called HTTP client body, but is now called HTTP request body. So that's what that rule would end up looking like. So Jack, we have about 5 minutes here.
Yeah, hey, I'm just responding to some questions here. I like this one from Roger. Suricata versus Snort. I can only implement one, you know, at home or whatever. Which one do you recommend? And it's a resounding Suricata, Suricata, Suricata. 100%. Just both from usage, detection capabilities, performance, and rule writing abilities, it's far and wide just the best. You know, I know Snort 3 is coming out at some point, but I would recommend Suricata over and over again. We at Emerging Threats, you know, we all offer a Suricata specific rule set. You know, we have a community and a paid version. The Suricata folks also offer their own kind of community rule set for various things. But yeah, like different networks gear like pfSense, OpenSense, all have plugins that'll allow you to run Suricata. And I would highly, you know, just recommend starting there if you had to just pick one. I think it gets developed faster because it's open sourced and community driven. So it's developed faster and with the kinds of things that the community wants and things that, you know, we typically get the most out of with it. So yeah.
A lot, you know, we deal with a lot of analysts that if you get to choose, that's awesome. If you get to pick what IDS you get to deploy, but you know, we deal with a lot of analysts writing rules that I don't get to choose what's in my network because it's been there for 10 years and it's there and it's still like Snort 2.6 or something. So, you know, you have to write for what you have, and you know, that's a good question.
Yep.
So yeah, so kind of wrapping up here. The more you look into your network, the more familiar you are with your network and what traffic you expect and don't expect, the easier all of this gets. And it definitely takes quite a long time spending with your network, or depending upon the size and whatnot, to kind of really understand that. You know, some of our rules, we didn't cover all of the options and things that we included in there just because this is a short session. But everything is well documented on the Suricata and Snort user manuals, and read the docs. And there is a ton of opportunity for anyone looking to kind of learn a new skill to get into this space, because you know, we probably do like 20, 30 rules a day that we push out for emerging threats for both the open and pro set. So this is still a very blossoming you know, space. There's still a lot of rules to write. There's still a lot of things to detect, and you know, we've been going through our rules and updating for Suricata 5, and we've found things that we used to do that, you know, we had to do them that way because that was all we had available. But now we have new things in Suricata that we're able to do and make much more effective rules. So some of our favorite kind of spots are the Ethiopian rule set and the Snort community rule set. Lots of great examples to kind of learn from. You know, you don't have to invent the wheel from scratch. Oftentimes you can find a rule that's similar to what you're trying to do, and then you can just kind of tweak it a little bit, or you know, see how the Talos guys write their rules, see how the ET guys write their rules. You know, everybody has their own little kind of unique ways that they do their detections. We're big fans of Security Onion, as well as you know, Brad's blog, Malware Traffic Analysis. He puts up PCAPs and challenges, and you know, we can't recommend those enough to everyone that's looking to kind of do this kind of network hunting, network detection type of work. Same thing for broad analysis. So we don't want you to leave empty-handed. We do have some workshop materials. Typically, we do a 4-hour workshop with a whole bunch of hands-on stuff, and we still don't cover everything that we do in the 2-day class. So if you want, you can check out the workbook at workbook.sigdevme.com, or no, I misspoke, workbook.sigdev.me. And that'll just take you to an Amazon Cloud Share that has a PDF, which is just kind of a workbook. You know, check out the workbook before you download the VM to see if it's something that you would like to spend your network bandwidth on. The VM, I think, is like a 3 gig download. So if you go to those locations, you'll be able to grab those materials and kind of work through it. Jack, do you want to speak to the workbook a little bit?
Yeah, sure. Yeah, the workbook is kind of just designed for, you know, at your own pace. Feel free to pop it open. It has the information like the username, password for the VM, some quick kind of startup information, and then just a handful of exercises looking at different protocols that we kind of discussed here: DNS, HTTP, TCP, TLS, things like that, from just all sorts of different malware. And yeah, it's kind of designed to work at your own pace. If you've never written a rule before, you will be able to write a rule. And if you've written tens of thousands of rules, you will be able to write a rule. And so, yeah, it's kind of got some follow along information and tips. And in addition, there's an appendix at the back of it, which has just a lot of shortcuts for buffers and how they're used, regular expressions and kind of some common regular expression stuff we use, and just kind of a quick start to, hey, I need to write a rule really quick, but I forgot, you know, does this protocol exist? Does this keyword exist? So yeah, it's just a nice little work at your own pace kind of.
I love that. I love that cheat sheet. I typically have it on my desk next to me when I'm like, what do we do for non-hex with Unicode, or what's the P-series for that, or what's the base64 P-series? Like, it's good stuff. Print it out, slap it up somewhere you can see it, and you'll be good. But yeah, I think that's our time. Do we have any outstanding questions or anything in the chat there?
I just have one here. To write rules, what external source could be used to be up to date with the latest threats? I would say the abuse.ch, malware bazaar, URL house. I would say Brad Duncan's website, malwaretrafficanalysis.net, app.any.run, the public sandbox there, has great samples. They have PCAPs, and they usually kind of tell you if it's bad or not. So yeah, I think any of those are good spots to start, just to find kind of the latest threat landscape. You know, whenever there's changes or new things, they usually find themselves there.
Yep, definitely.
And yeah, you can definitely follow us on Twitter. Feel free to email us. Our information is in the workbook as well. So if you pop the VM open and you have any problems, feel free to reach out to us. We don't get a lot of follow-up. So yeah, I mean, please reach out. We're more than happy to help. If you go through that and you want more, or it was too easy, we can definitely send you some stuff that'll make your head spin. So, feel free to, reach out with that or more. Additionally too, we've had people reach out just with their own rules that they're writing for their own network, whether they're hunting rules or just malware rules. We can help tune those for you. We can give some pointers. What would we do different? How would we do it different? We're here to help, and this is the stuff we live and breathe. So anything we can do to help, get everyone up and going and doing the best they can, we're here for that.
Yep. Yeah, and if you send us a rule, we have mailing lists and whatnot too that people contribute to, and contribute a rule, and we can get it out to the community, get it onto everyone's sensors, and you can help kind of defend everyone from the things that you're seeing. We love seeing contributions, and
Yeah. I mean, we release rules daily, Monday through Friday. And if anyone contributes, we usually give them a shout out. We make sure your contribution is recognized, and especially if anyone here is newer to InfoSec or newer to kind of blue team stuff, it's a really cool way to just get your name out there and be able to point to something and say, hey, I did that at a job interview or anything like that. We are getting a few requests for the slides. I don't know if there's a link.
Yeah, it'll be in the Discord. I'll be sending them over to Angelo, and he'll be putting them together with the other stuff.
Okay.
Yep.
So look for those in the Discord. Great. Well, any other questions or any last minute kind of things? We do, we do find ourselves teaching longer workshops. They're a little more hands-on, typically in like the 4-hour range. And we also have a 2-day course that we do teach that goes very deep into a lot of different corners and crevices of this kind of stuff. So if any of that is interesting, we can definitely.
Yeah, we love teaching that class so much. It's like everything that we do, all the tools that we use day to day, all of the things that we think of when we write rules, everything goes into that class. So yeah, love doing it. We love using Wireshark. I don't know how I would do my job without it. So I can't say thank you enough to everyone that works on Wireshark and all the awesome presentations that I popped in to see today. It's amazing.
Yeah, shout out Wireshark. Best open source tool behind Suricata.
Surishark.
Talk about SuriWire. Can't remember.
Yeah, I did mention in one of the chats on the Zoom or on the Discord. One of the OSF developers, Eric, wrote a tool called SuriWire, and it's just a Lua script that's kind of a plugin for Wireshark that will take the output of the eve.json file that Suricata produces, and then kind of feed all those alerts and all of that data back into Wireshark as additional fields that you can search on and filter on. Yeah, something that is really great for kind of getting used to working within Wireshark and working with the alerts.
Yeah, if you don't have a fully fledged elk stack or any tools like that, just that simple plugin can be a really cool way to enrich a PCAP and make it a little easier.